Today, we are going to explore a new type of graph, which is a radical graph. We've been dealing with adding and subtracting and multiplying these square roots and cube roots. And now we are going to jump into what they look like on a graph. So Miss Name, our 12th grade teacher, I don't know if y'all know her yet, but our 12th grade math teacher, she calls this the shooting star graph, right? So the graph starts, the parent function starts at 0, 0, the origin, and then it only extends out in this direction, right? So as it extends out, you'll see that it does not go into the negative. Does anyone have any idea why this graph, why this square root graph would not go into the negative? Why would this not go into the negative? Any ideas?
A negative times a negative equals a positive.
Ah, good thought. So if we have a negative times a negative, it equals a positive. Anybody want to build off of that? What about the square root of a negative? Can you take the square root of a negative?
No, you cannot. So it would be positive.
Well, it's not necessarily going to be positive. Oh, the number has to be positive. Yes, absolutely. Yeah. When you take the square root of a positive number, you get a positive number, right? When you take the square root of a negative number, you can technically get an answer. Does anyone remember what kind of answers you get? What kind of numbers? We typically say no real solutions. What's the opposite of real? Good idea. Good idea. That's one of those math words that feels right. Definitely. It starts with an I.
Infinite solutions? I don't know.
Ooh, good idea. Good thought. The word is imaginary. You get imaginary solutions. It actually has an I in it. So that's when you see answers like 2I, right? Or if you see answers like -9I, right? If you had 2I is the square root of -4, right? So the square root of -4 equals 2I. That is what happens, right? But you get these imaginary solutions and they're not graphed on a typical, sorry about that, totally changed the screen, so that was not helpful. Imaginary solutions are not graphed on a standard XY graph, right? They are graphed like in the third dimension. It's like a whole other thing. It's very cool. So what I want you to do is on this first page, I want you to just go ahead and explore what happens when I change A into some greater number. What's happening to my graph? Right? And then additionally, I want you to go ahead and move, like mess with the H and with the K to see what happens when you do this, right? To see what happens. Go ahead and you're going to play with slide 1. And then when you're ready, you're going to answer the question on slide 2, 3, and 4. You're answering the question on slide 2, 3, and 4 when you're ready. Oops, sorry about that, y'all. Hold on. There we go. Sorry about that. It booted you to slide 3. So if you need to go back to slide 1 to check that out, you totally can. And then you're answering the questions on slide 2, 3, and 4. I love the way that people are restating their questions, restating it. So for example, Brittany started with when I changed A in the equation. Now she's going to fill in the rest of her answer. Go ahead and move along at your own pace. So when you're ready, you can move all the way to slide 4. We'll come back in about 1 minute. Something to be careful of. The first slide 2 is specifically talking about what happens when you change A, right? So what happens when you're changing A? So when you changed it from 1, right? When A was 1 here, right? You get the red line. When A was 2 here, you get the blue line. When A is 3, you get the green line. So what specifically happens when you change A? Right. On slide 3, it's asking particularly about H. So what happens when you add or subtract a number inside of the radical? All right, I'm seeing lots of good answers on slide 3. If you are ready, go ahead and move on to slide 4. Talking specifically about K now. So what happens when we add or subtract a number at the end, but outside of the radical? Outside of the radical. All right. Looks like we're doing really awesome. I'd love to call on the following people to talk about each of the following slides. So JR, I would love for you to talk about slide 2 in a moment. Alvia, I would love for you to talk about slide 3 in a moment. And Brittany, I would love for you to talk about slide 4 in a moment. Let me know in the chat if you cannot do that. Or let me know that you can, actually, that'd be helpful too. All right. JR, can you talk to us about, oh, got it. Thank you, JR and Brittany, for letting me know. Awesome. Then for slide 2, I'm liking these answers. Ashley M, is it possible for you to speak for slide 2? What happens when you change A? What happens when you change A?
Slide 2?
Slide 2, yeah. So what happens when you change A here?
When I moved the slider A, it changed like the y-axis, like it would grow in height and it could even flip, like the yeah.
Yeah, when you say flip, do you mean flip to the negative side or flip to the negative side of the x-axis?
The negative side of the x-axis.
It's going to flip over here to the right side or to the bottom? Which were you saying?
I mean the y-axis.
Yeah, awesome. Thank you. So we can see here that A can make it grow. I like how Ashley said it could grow in height, right? It can grow in height. Or it can even flip over if you have that negative there. Absolutely. Elvia, can you talk to us about what happens when you change the H?
When you change the H, it goes left and right on the y-axis.
Yeah,
Oh,
absolutely.
the x-axis. Wait.
Good
Yeah,
correction.
I'm sorry.
No, that's okay. You did great. Right. So we can move to the negative side or to the positive side here. Definitely. And then Michelle, can you talk to us about what happens with K? Yeah, thank you, Michelle, in the chat. It moves up and down, right? So when we change K, it's moving up and down. One thing to notice, when you move H and K, it's not actually it's not making the graph bigger or smaller, it's just shifting it left and right, which means we can see more of it, right? So when we move K down and we move H to the left, it's not actually changing the shape of the graph. In order to change the shape of the graph, we have to use A in order to change that shape, right? So just something to keep in mind. I saw a few of us answering that. We were making it bigger when we changed H and K. We're just revealing more of the graph to ourselves, which is awesome. Cool. Go ahead and move to page 5. Move to page 5. If you're on some other page, go ahead and click over to page 5. Cool. For page 5, vocab alert. We have a point called the critical point, right? So the critical point is that starting location, right? If it was a full parabola, we might call it the vertex, right? But it is not a full parabola. It's not like a sideways parabola. That's called a hyperbola. But it is this critical point right here is where the graph sort of starts, if you think about it as that shooting star graph. The graph to the left is y equals the square root of x plus 4 minus 2. And the point at the beginning is called the critical point. The critical point is at h comma k, right? H comma k. So we see here it's at -4 comma -2. Something to note, your h value is the opposite of what you see in the equation. So just like if you're thinking about the same way that we were thinking about parabolas, how if it's in the parentheses, you have to flip it. The same thing is true for the radical sign here. So if we have the radical, we have +4 our h value is actually -4, right? It's the opposite sign of what that number is. Our y value is our k not changed. So since we see -2 here, we see -2 there. Okay. Go ahead and look at slide 6. On slide 6, it says circle the critical point on the graph. So you can use whatever color you want. Go ahead and choose a color. You're going to circle where the critical point is. You can put a dot on it if you prefer. Nice, seeing some good dots. Definitely looking good. Nice. And then you're going to put what are the coordinates of the critical point. So you're going to click in here, use your parentheses, coordinates of the critical point. You don't need to type a sentence in this case. Thank you for trying to restate the point here, but you're just going to go ahead and put the coordinates of the critical point. Awesome. Seeing lots of good circles. It is this point here, right? And then Blanca, if possible, can you give voice to what the critical point is?
Right now?
Yes, please.
Okay, so the critical point would be where it's circled. So if you
Yeah.
look at your x-axis and count 1, 2, then you go up 1, 2, 3. That would be your coordinates.
Awesome. 2, 3. Thank you, Blanca, for sure. Thanks so much. All right, go ahead and move over to slide 7 when you're ready. So for the next, I believe it's 3 slides. For the next 3 slides, you are going to change the numbers, right? So you can put a number here in A, you can put a number here for H, or you can put a number here for K. Your goal is to make this line shift so that this is your critical point, right? So you want to make this line move. So remember, if I change this to +1, it moves up. If I change it to -1, it moves down. So you're going to try to change these numbers in order to make this line shoot out of this critical point here. Go ahead and work on that one. And when you're ready, you can move all the way to slide 10. So you're working through all the challenges from slide 7 to slide 10. I'm going to go ahead and turn off the pacing at this point. So now you can be self-paced, move as quickly as you need to. Feel free to stop to ask questions if you'd like. So if I'm thinking about slide 7 here, I want it to move down to right here, right? So like -3. So instead of -1, I might try -3 like that. And now my graph has shifted down 3. Now I need it to shift to the right, +4. I need it to go +4 to get over here. However, since if I put +4 here, remember that it moves in the opposite direction, right? So I'm going to need to put -4 here in order to move it to the critical point, +4, -3. So you're just changing the graph that is here in order to reach that critical point. For those of you who are making it to slides 11 through 13, slides 11 through 13 are just reiterating. It's a multiple choice question. It's kind of like our checkpoint for today. So you're answering the question, and then you're responding why you think that is the answer. So you're answering the question, and then why that is the right answer. So same thing here for slide 8. You're going to be moving this graph to reach this critical point here. For slide 9, I'm seeing a couple really awesome responses. For slide 9 is asking you to make a line that goes through these 3 points, right? So I see some very creative answers, William Hamilton or Richard or Nina making multiple lines, but our goal here is to make one line that goes through each of these points. Right, so if you were someone who made 3 separate lines, really awesome idea. The directions were not that clear. So go ahead and jump back to slide 9. Your goal is to make one line that goes through those 3 points there. Same thing for slide 10. Same thing for slide 10. You're making one line that goes through those 3 points. So for slide 10, same idea here. You want one line that goes through the 3 rather than 3 that go through here. So if you're Katie Bowman, go ahead and try to make a line that goes through those 3 points there. Y'all are doing a great job. Continue to proceed at your own pace. All right, I am going to pace you for one moment. I want you to go ahead and jump to screen 14, and then we'll let you go back there. So you should be pushed to screen 14. For screen 14, it asks you to combine one graph with one equation with one explanation. sometimes it is hard because these are like randomly shuffled here to like get organized. So one way that I would recommend getting organized is by just taking the equations and for now popping them together, right? Take the explanations and pop them together like this, right? These do not go together. They are not pairs, but it just sort of allows you to say like, okay, this is what I'm looking for. This is where I'm at. You might make like 2 sets of graphic ones, just sort of like getting organized for those of us who like, it's a little overwhelming to see them all. You can move around the sets like this. You guys have done this before, but this would be my recommendation for getting started. So then you can decide how you want to do them here. You should have 6 groups of 3 cards each, right? So 6 groups of 3 cards each. So for example, I might start by saying, okay, well, this one's negative, and I know that the negative graph makes it go down. So I'm going to look for a graph that's going down and say, okay, it's got to be this one. It's the only one that goes down. Drag them on top of each other and they'll clip together, right? And then I'm going to look for an explanation. My explanation is the graph is going down because of the leading negative. So I'm going to go ahead and drag that together. What I know that this set is done because it has those 3 cards. So I'm going to go ahead and close it, and I can like kind of drag it off to the bottom. So it's not like in my way anymore, right? So now I can move through each of these ones here. You have, this is like the major mastery section of this assignment. Okay, so slide 14 and slide 15 are the same. They're the same strategy. You are just combining the equations. For slide 15, you just have the equation and the graph. You do not have the explanation. Okay. Are there any questions about what we're doing here, what your assignment is for today? What you are turning in is this page here. So I know some of you are probably screenshotting as you go, but you are going, like, what you're going to go ahead and turn in so that you know that you have it done is this slide. You're just like going to take a screenshot for whichever slide it says to take a screenshot of. That is what you're turning in today. There is extra credit at the bottom if you'd wish. There's a gim kit to play, so you can play the gim kit. If you play it for like 1 minute and then you hate it, you still get a little bit of extra credit. So feel free to jump in. That's totally fine. If you love gim kit and you want to play for the whole time, I think it will time you out at 20 minutes or when you win the game. So you do have extra credit available to you. That is it for today. So we should be pretty close. I've totally unlocked you. So you can go back to slide 10, slide 11, slide 7, whichever slide you are on. But that is our goal for today. Are there any questions about our decimals? Awesome. Okay. Per usual, I'm going to end us with how are we feeling about this? If you can click back into the Zoom, if you're like on your decimals, you should see a poll at this point. How are you feeling about this topic? Are you at 0? Like you're like just totally guessing on the decimals? Are you like a 3? Like you're sort of there, all the way up to a 5? Like you get it. It totally makes sense. Everything is good. And Antoine, did it let you vote in that poll? I'm just trying to know for my.
No, it doesn't.
No. Okay, it's because I made you a co-host. Thank you for letting me know. Awesome. Great. Glad to hear it, Antoine. That was a good strategy. I didn't even think about that. Thanks for putting it there. Awesome. Thank you for letting me know. Cool. All right, I'm going to go ahead and end this poll. This is where we are at. The highest percentage was 4, lots of 5s as well. A few 1s and 3s, that is totally a fine place to be. If you are a 1, a 3, or a 4, and you're feeling like I could use a little bit more support, Miss Yamanaka is going to be available at 10:30 today to support you with finishing your assignment as well as answering any specific questions that you have. That being said, we're going to be done 2 minutes early today. Please make sure that you submit this as soon as possible and reach out if you have any questions. Other than that, y'all have an amazing day, and I will see you on Thursday. Bye, friends. I am recording. I'm going to stop the recording right now, but it'll be posted on YouTube if you need to go back and watch again. So let us know. Thanks, y'all. Bye, JR. Have a good day.